And I'm going to take this function, I'm going to find the derivative of that function.
And you guys have already practiced this by finding the derivative of a line, or I'm sorry, of a curve.
Of a curve. And so we're looking at the tangent line, and we're going to find the slopes of this. And it's going to find all these slopes. So that blue line going across the stage, or the screen, those are positive slopes, positive slopes, positive slopes, oh, positive slopes. So the blue line coming down here was all the values of the slopes. It's now at 0. Negative slopes, all those points are negative, negative slopes, negative slopes, negative slopes, oh, 0. And then we start to get positive again.
So what do you notice about this function? What does it look like?
Right, well, we've seen these curves before. That looks like a parabola, like an x squared type of function. This was x cubed. This is x squared.
So just from that, you should notice we're going from an x cubed to an x squared. Hint, hint.
Hint, hint. Let's take the derivative of the blue function that I just made black. Okay, let's take the derivative of this one now. Take the derivative, and we get a negative slope, negative slope, negative slope, negative slope, negative slope, still negative, 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 negative slope. You'll start to see the point soon. Negative slope, negative slope, negative slope. 0 at the minimum, 0. Keep on going positive slopes.
Now that's a line.
Now that dotted line is a line. So when the original function was an x cubed, the red one was x cubed, blue was x squared, and then just plain old x.
So what do you notice about the exponents?
It seems like they're always going down by 1.
Okay, so let's go back to our rule.
All right, so it sounds like we're ready to talk about the power rule. So given a function y equals x to the power n, then the derivative, well, the derivative is going to be that power is going to subtract by 1.
So we already know that x is now going to be x with n minus 1.
Because it went from x cubed, x squared to x as we took the derivatives.
And we also know one more thing.
Right. That n that was over first in the derivative, it comes down front. So it's n times x to the power n minus 1. That's the power rule. Let's take a look.
That's in your formula pack too.
Right. Let's take a look and do an example. So here's f of x equals 1/3 x cubed minus 2x squared plus 4.
These are so fun.
They are.
Okay, find the first and second derivative. I'm just going to say f prime of x.
Super.
So that equals...
So I have 1/3, and
I always like to bring my power out first.
Oh,
do
okay.
you do the 1/3 first? I always do that. So I do 3.
3, okay. Power comes down.
1/3 x.
And the 3 becomes a 2 now. We subtract 1.
Minus.
Bring the 2 down.
2 times
2. The x.
And if I had something written here, it would be x to the 0. So what happens when I bring that 0 down? That whole
Function,
constant is gone.
Right, it's gone. It's just 0.
So now we're left with 3 times 1/3, which is just 1. So I have x squared minus 4x.
And that is the first derivative.
Well, the second derivative, now I could just write double prime.
Mm-hmm.
Follow this process again, bring my 2 down in front, 2 times x, minus, bring my 1 down on in front, 4, now this becomes a 0, which is just 1.
Excellent, right. And then our third derivative, we could keep on going this for a long time,
is
2.
2.
Bring the 1 down, 2 times 1, and there's just 2 left. And there is our first derivative. Now, we're going to check the first derivative with our calculator. All right, so if we go to our calculator now, let's put in this equation. 1 divide 3 x to the power of 3.
Make sure that you are being an active listener as we're going along and you are typing stuff into your calculator. Maybe you can move a little faster than us, pushing pause, solving the problem before us.
Okay, so if I just graph this function, it looks like that. And I want to graph the derivative now. So what I'm going to do is I'm going to go to y equals 2, and there's a couple ways to do this one. If I go to math, and I toggle all the way down to number 8, n deriv, I want to find the derivative of y1. So I should maybe put my key history up so you can see what I'm clicking. if I go now vars into y variables to function 1, I want to take the derivative of the y1 with respect to x, and I want to do it to every single x. And if I graph that, there it is right there.
And we can find the name of that graph just to check our work, right? Just hit trace.
Ah, right. I think it'll, if I hit trace, it might just give me, just end derivative.
Oh, does it? Okay.
Yeah. There are other ways to do it too, but this is the one I'm going to concentrate on right now. And this is the...
I guess we could check it just by putting it in our equation if we wanted to and make sure that they lie on top of each other.
Yep, that's a good idea. Let's do that. And so then we come over here, and if I type in what I believe my function was...
X squared minus 4x.
X squared, squared minus 4x. And let's go on top over here, make it bold so we can see where it's going. Make it bold, and let's graph. And it goes right on top. We're good. Okay.
All right.
Let's do one more example here.
All right. Given that y is the cube root of x minus 1 over x squared plus 5 times x to the 10th minus 2 over the square root of x to the 5th. Find the derivative.
Ooh, wow. So dy dx we got to find.
Well, first, you know what I like to do is rewrite this because these are hard to see what the power really is.
You're so on top of this.
So this is x to the 1/3 minus. Now instead of saying 1 over x squared, I can just say that's the same thing as x to the negative 2 plus 5 x to the 10th minus 2 times x to the negative 1/5.
Oh, no, we gotta go.
Oh,
it's on the bottom of the fraction. We gotta.
It is 5 over 2.
Yeah, we have 5 over 2.
5 over 2.
There we go.
Okay. All right.
dy dx. We bring our power down 1/3.
Times x. Subtract 1 from here, I get negative 2/3. Minus, bring my power down, negative 2. Subtract 1 from the power, negative 3. Bring my power down, 10 times 5 times x to the 9th. Minus.
Bring our negative 5 halves down. Oh, don't forget your negative sign there.
Thank you. Minus 5 halves to x to the negative.
We're going to put our 2 as well.
This is why it's good to do it in pairs. Okay, so 7 halves.
7 halves.
All right, that's really ugly. We got to clean it up.
Yeah, let's make it look a little bit nicer. So, not much we can do with the first part. So we get 1/3 x to the negative 2/3 plus 2x to the negative 3 plus 50x to the 9th
plus 5.
Right, because the 2's cancel.
X negative 7 halves.
Sweet. Nice.
Okay.
Right, I don't know if we have one more or not. Nope, that's it for now.